Not
basically.
every star becomes a black hole at the end of its life?
No, because if something like the sun,
We have a
then
small star.
it's quite small, yeah, and when it collapses, there's a sort of a pressure, a force, if you like, which is caused by the fact that electrons don't like to be very close to each other. So it's called the Pauli exclusion principle. But essentially what happens is that, so as they get squashed closer and closer together, they move faster and faster to sort of get out of each other's way, if you like. And that makes a force which holds them up. And so that creates what's called a white dwarf star. So you can have a blob of matter. They're about the size of the Earth, but they're about the mass of the sun. And so that's for smaller stars. They end up as these white dwarf things, which are very dense objects. There's another version, which is called a neutron star, which is the same thing, but for neutrons. And they move faster and faster. So if it's massive enough that it overwhelms the electron thing, then the electrons sort of crush into protons and turn into neutrons, and the whole thing starts again. And so a neutron star can be, at least 1.5 times the mass of the sun, let's say, but it can be about 10 miles across. So that's an incredibly dense ball of matter held up by the neutrons moving around. It's got a fancy name. It's called neutron degeneracy pressure, but that's what it is. But if you go even bigger, then even that can't hold it up. And as far as we know, then there's no known force that we know of that can hold the thing up if it's too massive. And so that's when it just almost winks out of existence, if you like. It collapses and collapses and collapses, and that's when you get a black hole.